For the first equation here, the least common denominator is between 2, 5, and 4. That's going to be 20, which means I'm going to multiply that to every single term. So that's going to be 20 over 1, we'll have a 20 over 1, and another 20 over 1, multiplied to the original expression, which is going to be 1/2 minus, then we have this x plus 1 over 5, and that's equal to 1 minus x over 4. All right, so with these values, 2 goes into 20 10 times, 5 goes into 20 4 times, and 4 goes into 20 5 times. If I'm careful in writing the next step, I have 10 times 1, which is just 10. Now this is minus 4 times x plus 1 in parentheses. Likewise, on the other side, we have 5 times 1 minus x. I'll now distribute the negative 4 and this positive 5. I get 10 minus 4x minus 4 is equal to 5 minus 5x. I'll combine some like terms, so we have negative 4x and a plus 6 is equal to negative 5x plus 5. Doesn't matter if you reorder that or not. I think I'll add 5x to both sides, as well as subtract 6, and we get x is equal to negative 1. For part B, I'm going to distribute the negative 2 as well as this positive 7, and this gives us 5 minus 2x minus 2 minus 4x is equal to 2x plus 7 minus 7x. I'll combine like terms, and we get negative 6x plus 3 is equal to negative 5x plus 7. I guess I'll add 5x to both sides, as well as subtract 3. So we get negative x is equal to positive 4. Okay, I gave myself an extra step of dividing both sides by negative 1, but x is equal to negative 4 is my answer. Okay, I need to set up two equations for C. That's 1 minus 3x is equal to 37, but also 1 minus 3x is equal to negative 37. I'll subtract 1 from both sides in both equations. I get negative 3x is equal to 36. I get negative 3x is equal to negative 38. And dividing both sides by negative 3 in both equations, I get x is equal to a negative 12, and then I have x is equal to positive 38 thirds. I guess I'll leave this as a fraction, it can't be simplified, and those are the two answers. For D, I want to solve for x, so I'll distribute the 2 into the parentheses on the second one here and the 5 in the first set of parentheses. We get 5x plus 10y is equal to 2x plus 4y minus 4. I guess I'll subtract 2x from both sides, as well as 10y. And I get 3x is equal to negative 6y minus 4. And if I divide both sides by 3, I get that x is equal to negative 6y minus 4 over 3. You could factor the negative out of the numerator. You could write your answer as negative times, it would be 6y plus 4, right? Because if you multiply this to the numerator, it would have to be distributed to both terms. And divided by 3, both answers are completely okay. All right, for 2a, this is a less than with an absolute value, meaning I want negative x plus 8 is less than 12, but that's also going to be greater than negative 12. I can now subtract 8 from both inequalities, giving me negative 20 is less than negative x is less than 4. Now this time if I divide by negative 1, it's actually going to reverse the direction of each inequality. This will be 20 is greater than x is greater than negative 4. And for me anyways, just ordering it from like smallest to largest, this is more meaningful. So I'll put negative 4 is less than x is less than 20. These are all the numbers that make this original expression true. Okay, so for part B, all right, I think I'm going to combine some like terms first. I see on the left I have a 5 and a 1. That's 6 minus 2x is greater than or equal to 10x minus 17. I think I'll add 2x to both sides as well as add 17. Okay, when I do this, I get 23 is greater than or equal to 12x. Okay, I can now divide both sides by 12. This is a positive number I'm dividing by. This means I do not change the direction of the inequality. That's 23/12 is greater than or equal to x. For the last part here, we have a greater than with an absolute value, meaning I have to write this as an or statement. Where is 2x plus 1 greater than 10, or where is 2x plus 1 less than negative 10? We're on the outsides of both 10 and positive 10. So I will subtract 1, which gives me 2x is greater than 9, or where is 2x less than negative 11? I'll now divide both sides by 2. This does not change the direction of the inequality, but I get 9 halves, or x is less than negative 11 halves. Those are the solutions. Okay, this time we are going to decrease the concentration of acid in this solution. So we're starting with something that's 20% acid. We're going to incorporate this 5% acid to drop it down to 18%. X is going to be the liters of 5% acid. So in my equation, I'm going to start with how much acid is in the 5 liters, and I'm going to add into that some number of liters of the 5% acid solution. I want this to just be one solution at the very end whose concentration is 18%. So it's going to be some percent times an amount. And the amount of stuff in there is going to be the 5 liters from your first solution plus however much you're adding from the second one. This is my equation. This side is what I mixed together, and this side is what I end up with. I mixed 2 separate things, so I had 2 separate terms, always a percent times an amount. On the other side, what I end up with, it's just one term, a percent times an amount. So let's go ahead and solve this. Okay, let's see, I get 1 plus, I can only write that as 0.05x. And if I distribute this 0.18 to both terms in the parentheses, okay, 0.18 times 5 is 0.9 plus 0.18x. I think what I'm going to do is subtract the 0.9 from both sides, as well as subtract the 0.05x from both sides. Okay, and when I do this, I get 0.1 is equal to, okay, then I have 0.13x. I'm going to divide both sides by 0.13. And I get my final answer of 1/13. So let's actually write that out. That's actually 10/13. So this is 0.7692. I'll go out to 4 decimal places. I mean, you could round it to 2 decimal places, but it's approximately 0.77 liters that you're going to pour in to decrease the concentration of acid. I wasn't expecting it to be a large amount, and that's because I was only decreasing by a little bit, and that's my final answer. Okay, so finding the equation of the line between these 2 points, again, my equation has to be of the form y equals mx plus b, where the slope has the formula y2 minus y1 over x2 minus x1. You can order the points however you like in part A. I think I'll let this be y2 2x2, and this is going to be my y1, x1. So let's see. M is going to be y2 minus y1, which I'm doing minus 3.5 minus a negative 1.5, divided by x2 minus x1, which is negative 1 minus 3. All right, when I simplify this, that's going to be negative 3.5 plus 1.5. Okay, so that's 2. Negative 2 over negative 4. And that means my slope is 1/2. You could even use a decimal of 0.5. That would be completely okay. All right, now that I know my slope, I think I'll leave it as a fraction. My equation has to be 1/2 x plus b. The only thing that I do not know is b. And you could use either point that you would like. I suppose I'll use the second point. I'll put 3 in place of x and negative 1.5 in place of y. That's negative 1.5 in place of y. I get 1/2, and then I have 3 plus b. Okay, 3/2 is 1.5. So that's negative 1.5 is equal to 1.5 plus b. And if I subtract 1.5 from both sides, I get negative 3 is equal to b. This gives me my equation. I know the slope was 1/2 and that the intercept was negative 3. I can now use this to figure out what the x-intercept is. I'm going to put 0 in place of y and solve for x. That is 0 is equal to 1/2 x minus 3. I'll simply add 3 to both sides. So I get 3 is equal to 1/2 x. I'm going to multiply both sides by 2. Or if you'd like, 2 over 1. What this will do is cancel the 1/2 on the right, and I get 6 is equal to x. That means my x-intercept has coordinates of 6, 0. To graph this line, I think this time I'm just going to use the slope and the y-intercept. So the y-intercept was at negative 3, and the slope is 1/2, and that means I go over 2 up 1. What do you know? I actually end up at 6, 0. That was the x-intercept right there. I think I have enough points to really sketch my line, so I'm just drawing the equation that goes between these points. And that's my answer. All right, I want to know the domain and range for this graph. So again, the x values represent the domain. And systematically going through these points, starting with this one, the x value here is negative 3. The x value here is negative 2. This has an x value of negative 1. This has an x value of positive 1. And here we have an x value of 4. For the range, I want the y values. So I'll start with this lowest one. This has a y value of negative 3. These 3 points all have the same y value of positive 3. You only have to write it down once. Okay? And here, this has a y value of 4. And that's it. Those are the only y values between these 5 points. Now, is this thing a function? So that's the last question. It's either yes or no. And all you have to have is that for each point that you pick, there's never a second one above it or below it. If that happens for every single point, you do in fact end up with a function. If I start with this one here and I look up and I look down, I don't see anything, so this point's good. This point has nothing above or below it. Again, we're good. This one, nothing above or below. There's this point here, there's nothing above it or below. And this one has nothing above or below, and that's it. That meets the definition of a function, so the answer is yes. Let's solve the following system of equations. I think I'm going to use the addition method. I think substitution would be fine here. Like you could solve this equation for x pretty easily. But instead, what I'm going to do is multiply this equation by 2, and I'm just going to leave the second equation alone. I'm not going to do a thing to it. Then I'll put a negative 2 here. I already have a positive 2 here, and when I add the two together, those completely cancel. My first equation becomes negative 2x plus 4y is equal to 16. And I left the second equation alone. It's 2x plus 3y is equal to negative 2. If I add these together, I get, what do we have here? The x's are gone. 3y and 4y is 7y. And 16 plus a negative 2 is 14. This one's going to work out nicely because if I divide both sides by 7, I get that y is equal to 2. The only thing that I don't know is x. I think I'll go back to the very first equation and figure out what that is. So I'm going to take negative x plus 2y is equal to 8 and simply put y is equal to 2 here. Negative x plus 2 times 2 is equal to 8. So negative x plus 4 is equal to 8. If I subtract 4 from both sides, I get that negative x is equal to positive 4. But if I divide both sides by negative 1, I get that x is equal to negative 4. And this is my solution. X equals negative 4, y is equal to positive 2, and that is it. Okay, last one here. Solve the following system of linear inequalities. Again, my first approach is just seeing if these two things intersect each other, meaning I'm going to set the two equal to each other. So let's see. I'm going to take negative x minus 3 and set that equal to x plus 5. I think I'll simply add x to both sides and also subtract 5. This gives me negative 8 is equal to 2x. And if I divide both sides by 2, these intersect at negative 4. So I'll just keep an eye out for that when I graph these two equations. Let's start with the top one. We have y is greater than negative x minus 3. There's no equal sign, so it's going to be a dotted line. Let's see, negative 3 is the y-intercept. The slope is negative 1, meaning I go over 1 and down 1. So my line is going between these points. So it doesn't have to be perfect, but I'll try to sketch something nicely between these. There we go, my dotted line. For the second one, I have y is equal to x plus 5. I have an equal sign there, so I actually want a solid line. I graph the first one. The second one is going to be, okay, 5 is the y-intercept. The slope is positive 1. So I'm going between these points. And okay, these in fact do intersect at x equals negative 4. That's great. They both have a y value of 1 there. So my line is a solid line. It goes through here. There's only one thing to do. It's now decide which of these 4 regions work for both of those equations. Okay, so I think I'm first going to choose, I don't know, maybe negative 5, negative 5. I'll start with this one here. I mean, I guess we could go with 0, 0. That would be fine too, but not really sure which one. All right, maybe I will start with 0, 0. So let's see if it works here. I usually say start here because it's the easiest one to plug in, so why not continue to do that? I'm going to put 0 in place of both x and y in both of my inequalities. Are they both true? Well, the first one's good. We have 0 is greater than negative 3, but unfortunately the second one is false. 0 greater than or equal to 5 is false. So no, this did not work. So I know I don't want to choose this region. This is no good. So you could choose 3 others. Like you could choose 0, negative 5 for this bottom one. you could choose negative 10, 0 for the second one. Or like I said negative 5, 5. But I think I'm actually going to switch it over to 0, 10, just because one of the coordinates is 0. So I want to check this region up here. So I'm going to choose this spot. So I'm going to check 0, 10. Okay, I plug that into the first inequality. 10 is greater than negative 0 minus 3. And also, is 10 greater than or equal to 0 plus 5? Are both of these true? Well, for the first one, we get 10 is greater than negative 3. That's good. And for this one, we have 10 is greater than or equal to 5. That's good too. Boy, I really wish I started with this region. I mean, so my answer is going to be all of this stuff here. All of these points work in both of these inequalities.